There are millions of diseases, and most of them have one purpose. It is to accomplish death. To put life simply, it is the constant supply of energy in the form of ATP. And when this energy supply isn't available, death occurs. We talked about death extensively, but that was the loss of life to the entire organism. Now let's get smaller and talk about another interesting kind of death: apoptosis. Apoptosis is programmed death, and this is the kind of death necessary for the cells so they could be reborn. It's a vital biological mechanism for maintaining tissue homeostasis, development, and removing damaged or unwanted cells. This contrasts with necrosis, which is a messy and uncontrolled cell death that can cause inflammation. Our cells face life-threatening situations all the time, where examples will be errors, mutations, where some render them dead. The lifespan of our cells vary, and naturally, they are meant to die within a short period of time, so we can regain new sets of cells. Life proceeds, and this is why ATP is so important. But these are just the normal cellular experiences, where they go about their activities and die at the end. But what do these cells do when faced with actual life-threatening situations outside errors and mutations? What if they are faced with bacterium and viruses? The immune system. The human immune system is a complex network of cells, tissues, organs, and molecules that defends the body against infections and foreign invaders such as bacteria, viruses, fungi, and parasites. Components of the immune system: we have white blood cells, leukocytes. These are key players that identify and destroy pathogens. Lymphatic system: there is a network of vessels and lymph nodes that transport immune cells and filter pathogens. Bone marrow is a site where blood cells, including immune cells, are produced. Thymus is the organ where T cells mature. Spleen: it filters blood, recycles old red blood cells, and stores white blood cells. Mucous membranes line respiratory, digestive, and urinogenital tracts, secrete mucus to trap pathogens. Now, types of immunity. We have innate immunity. This is the first line of defense, non-specific, and it is present from childbirth. Adaptive immunity is specific to particular pathogens, develops after exposure. Passive immunity is a temporary immunity gained through transfer of antibodies. Example, from mother to baby. Active immunity, long-term immunity developed through infection or vaccination. Now, innate immune response, physical barriers. We have skin, the mucous membranes. Chemical barriers, we have enzymes in saliva, stomach acid, antimicrobial peptides. Cellular defenses, we have phagocytes, that's neutrophils and macrophages, and natural killer cells. Inflammation, we have redness, heat, swelling, and pain to contain and eliminate pathogens. Fever, this is the rise in body temperature to inhibit microbial growth, and this forms the innate immune response. Now, adaptive immune response. Lymphocytes, T cells and B cells are central to adaptive immunity. Now, T cells, helper T cells, that's CD4+, activate other immune cells. Cytotoxic T cells, CD8+, these kill infected cells. B cells, it produces antibodies specific to antigens. Memory cells, they retain the memory of past infections for faster response upon re-exposure. Now, antibodies, immunoglobulins, proteins produced by B cells to neutralize pathogens. They bind specifically to antigens on pathogens. Types, we have IgA, IgD, IgE, IgG, and IgM, each with specific roles in immunity. Now, how immune system fights diseases. This is how they do it. They detect and destroy foreign invaders. They create memory cells, MHC, after exposure to prevent reinfection. They activate inflammatory response to contain the infections. They use antibodies to neutralize or mark pathogens for destruction. And then they eliminate infected or cancerous cells through cytotoxic T cells. Disorders of the immune system. Immunodeficiency. This is the weak immune response. This is due to HIV/AIDS. Autoimmune diseases. Immune system attacks body's own tissues. Example, we have lupus, rheumatoid arthritis. Allergies. Overreaction to harmless substances. Transplant rejection. Immune system attacks transplanted organs. Vaccination and immunity. Vaccines stimulate the immune system to produce memory cells without causing diseases. Provide protection by repairing the body to fight future infections effectively. Now, its importance. The immune system is essential for survival and health. It protects against a wide range of pathogens. It maintains homeostasis by eliminating harmful or abnormal cells, and plays a role in cancer surveillance and defense. Our cells survive these situations, get hit, fight, and then die, only to be reborn even stronger than before, thus being able to resist past struggles and face new challenges.